Alright, this is part 5 of our lesson on graphing rational functions. I'm finally getting to the last video. This is crazy. So number 11 is where we're picking up at. Alright, X-intercepts. How do we find them? We set the numerator equal to 0. So that would be 3x equals 0, divide by 3, you get x equals 0. Alright, so that's 0, comma 0. And we might as well graph that. Okay, so x-intercept. There's our x-intercept. Alright, you know that's going to be a y-intercept as well, alright, because it's touching the y-axis too. But I guess we'll cross that bridge when we come to it in 10 seconds. The y-intercept. How do we get the y-intercept? Well, I'm glad you asked that. We let the x values be 0. So if I let x be 0, that means I have a 0 here, and here, and here. Alright, but if that's 0, look, 3 times 0 is 0. So that's going to just make 0 over negative 2, because this is all gone. But 0 divided by anything is 0. So the y-intercept is also going to be 0. So 0, comma 0. Alright, like I said a moment ago. So moving on to the vertical asymptote, or bzz. To find the vertical asymptote, how do we do that? How do we find the vertical asymptotes? Yeah, we set the denominator equal to 0, of course. So we're going to go x squared minus x minus 2 equals 0. Probably this is factorable. X squared being x times x, 2 is 2 times 1. I'm feeling a negative 2, positive 1 coming on, because inner we have negative 2x, outer we have positive 1x. That makes a middle of negative 1, yay! And a negative times a positive is a negative, so score. Now we set these equal to 0, right? So we got x minus 2 equals 0, x plus 1 equals 0, so x equals positive 2, x equals negative 1. Again, we're finding vertical asymptotes, so we have two of them, negative 1 and 2. Please put x equals 1, x equals negative 1, x equals 2. Don't just put negative 1 and 2. You will lose points for that. Now, let me clean up my mess here. And now let's talk HA, horizontal asymptotes. Okay, how does that work again? One more time. Horizontal asymptotes work like this. We pay attention to the degree. Is the numerator degree less, equal, or greater than the denominator? Because that'll tell us which case we're in. Well, let's see. The degree of the numerator here is 1, because x to the 1 power. The degree down here is 2, because of x squared. So the degree of the numerator is less. If the degree of the numerator is less than the degree of the denominator, y equals 0 is the horizontal asymptote. Okay, great. So that means the horizontal asymptote is simply y equals 0. So let's go ahead and graph these three asymptotes. Next, it is time to pick our x values. Let the asymptotes be your guide, the vertical asymptotes. We're going to definitely need points to the left and the right of every asymptote. Now guys, I said this on previous videos, but maybe you jumped straight to this one, so I'm going to repeat. Look at this asymptote. In addition to whatever other points you use, I want you to pick values just barely to the left and just barely to the right. So I'm talking decimals, okay? So this vertical asymptote is at negative 1. So if I go half of a square over, that's going to be negative 1.5. Okay, let's definitely do that. So negative 1.5. Alright, the reason why, when you're close to the asymptote, you really get to see where the function is headed. You know, whether it's headed up or down or what's happening, you get a much better view. So always, always use values like a half a square away on either side. So on the right side of this asymptote, okay, it would be negative 0.5, would be halfway over, okay? So negative 0.5, like 0.5. Let's definitely do that. Okay, let's do the same thing with the other asymptote. This is at 2. So 1.5 would be half a square on the left. 1.5. So let's definitely do that. Okay, and how about 2.5 would be just barely to the right. Okay, those are all great values to use. Now, what else? What other whole number values can I maybe use? Well, you know what? There's one more decimal I'd like to see. You know what? Never mind. Okay, whole numbers now. So, let's do -2. Okay, a nice whole. We did half a square over. Let's go ahead and go the rest of the way. So let's go ahead and throw -2 in there. Okay, going to the right over here, we did 1/2. Let's go ahead and see what's going on at at 3 right there. Let's check that out. Okay, how about in this situation? How about, let's see what's happening at 1. We have the -1/2. We already have the y-intercept. We have over here. So let's go ahead and do 1. Okay, so this is a good set of 7 points to start off with. If we need more, we can always get more, okay, off the calculator. So, yeah, so let's put this function once again into our TI-30 XS multiview. Okay, so table function, yeah, let's clear out what's in there. So we have 3x over x squared minus x minus 2. So x squared minus x minus 2. Hit enter. Let's definitely use the ask feature. I like it. So let's see what's going on. So -1.5. So -1.5. Okay, that's this. Toggle it. That's -2.6. -2.6. -2.6. -0.5. Oh, well, it's already there. -1/2. That's this. Okay, so that's 1.2. And 1.5. That's this. Let's shimmy on over there and toggle it. That's -3.6. -3.6. Okay, and go ahead and find the rest of these values. I'm going to do it off camera. You should do it yourself and see if you agree with me. Alright, so these are the y values that I got, and now I'm just going to go ahead and graph them and see how they look. Okay, so these are the points that I got when I graphed these. Alright, and this gives me a pretty good idea of what is going on. Okay, I might just do a couple more points. I think I'm just going to do, let's say, -10 and +10, just for fun. Okay, so let's see. -10 and +10. Okay, so -10 gives me -0.3. Okay, so at -10 I am right here. +10 gives me this, which is +0.3. Okay, which is here, which is what I thought, but it's good to just see it. So now I have a really clear picture of what's going on. Alright, this branch is doing this type of a thing. Okay, alright. that was pretty bad. Let me try it one more time. This is tough to do with OCD. Okay, this middle part is clearly, it just passes straight over that horizontal asymptote, which is okay. Alright, the horizontal asymptote is not a barrier like the vertical asymptotes are. It's really just there for the end behavior of it. Okay, so this part swerving in here is like doing something like this. Okay, and then this part is doing something like this. Okay, so your graph should look very much like this. Now, domain, range, increasing, decreasing intervals. The domain. The domain, we're looking from left to right and observing the x values. Every x value is represented except for the vertical asymptotes. So I'm going to have to split the domain into these three parts. Hold on, let me save this before something bad happens. Okay, so the first branch here goes from negative infinity to negative 1. Alright, it goes from negative infinity to this asymptote. Negative infinity to negative 1. Okay, union. And then we've got this middle part here which goes from negative 1 to positive 2. Okay, so negative 1 to 2. And then the third branch picks up at 2, well, after 2, and goes from 2 to infinity. Alright, obviously I'm leaving these all round parentheses because you don't reach the asymptotes. They cannot be included. Now the range is easy. Even though there's an asymptote here, this middle part just cut straight through it and went on through. We even have a value right on the asymptote. So every single y value is represented. Alright, nothing is skipped over. So that's why the range is a nice, smooth, negative infinity to positive infinity. Okay, no gaps. Now, the intervals of increasing and decreasing. Let's just count them off from left to right. So first we have this branch over here. And as I trace from left to right, it goes, you see it dropping. So that's decreasing. Again, x values. This is from negative infinity to negative 1. Alright, it goes from negative infinity to the asymptote. Don't say negative infinity to negative infinity. That's not an x value. It's negative infinity to negative 1. And that's decreasing. Okay, now how about this middle part? This middle part, as I trace this, it's falling, 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 falling. The entire way, it's decreasing. This whoosh. So that's decreasing from negative 1 to 2. So another decreasing interval from negative 1 to 2. Now how about this last part? Again, a decreasing interval, which goes from 2 to infinity. 2 to infinity. Okay, so a third decreasing interval from 2 to infinity. Okay, so every part of this graph was decreasing. Downhill, downhill, downhill. It goes downhill. So there are no increasing intervals for this graph. Symmetry? Not quite, okay? It was almost odd. But look at the asymptotes. Look at the asymptotes. See how this asymptote is just 1 to the left, but this asymptote is 2 to the right. that means that the origin is not the center of rotation. Okay, so symmetry, neither. Now in the last graph, it was ugly, okay? We had to estimate the domain and range and the increasing and decreasing intervals. We didn't know exactly what was going on. And I said, if I give you one like this on the test, it'll just be a graph. And I won't be asking you for the domain and range. Well, the domain was fine, but I won't be asking you for the range or the increasing or decreasing intervals. But this one is nice. So this would be a really good graph for me to give you and ask you about the domain and the range and the increasing and the decreasing intervals. It's all good. It's all good. Alright guys, I have spent a lot of time making these videos today. Please make sure that you can do these problems by yourself. Some of you are just following along with me and you're just copying the video. Some of you aren't even listening to this. You're just pausing the video and just copying the picture. Some of you aren't even watching the video. You're just pulling up the answer key and copying that. Okay, but you know what? When the quiz comes, when the test comes and you fail, that'll be why. So please make sure, if you've been copying off me, go back and do it again by yourself this time if you want to pass. Alright guys, I hope I was able to help you out a little bit. I will see you on the next video.